For as long as humans have gazed upwards, we have been captivated by the cosmos above us. This innate curiosity has fueled a millennia of scientific discovery, pushing the boundaries of what we thought impossible. Already having a constant human presence aboard the International Space Station, the prospect of colonizing extraterrestrial bodies is beginning to seep into reality, especially with our interest in our red neighbor, Mars. This begs the question, could we make Mars habitable? Before we could get into that, we need to know if Mars is suitable to be terraformed. Mars is a celestial body, half the size of Earth. It is 248 million kilometers from the Sun, 55 million kilometers from Earth at its closest, and 401 million kilometers at its furthest. Mars has a tilt of approximately 25 degrees, and its days are just slightly longer than Earth's, measuring 24 hours, 39 minutes, and 35 seconds. Mars also takes 687 days to orbit the Sun. Mars's atmosphere is roughly 100 times less dense, or less than 1% of the sea load pressure on Earth. Mars's atmosphere mostly consists of 95% carbon dioxide and other small amounts of nitrogen and argon. Mars also has no magnetic field. Now, how could we make it Earth-like? We could try importing carbon greenhouse gases onto Mars from one way or another, or even detonate nukes above the Martian pole to release CO2. But there is one glaring problem. Mars can't hold on to an atmosphere because it has no magnetosphere, or a magnetic field. Without it, the solar wind, consisting of charged particles such as protons, electrons, and other particles, would eventually strip away the atmosphere. Currently, there is no feasible method to restart Mars's magnetic field, so I suppose there isn't hope of living on Mars? Well, not really. Even though we won't be able to terraform Mars, we could certainly live there. Even if we could create habitation vessels to live there, we'll have to worry about solar radiation. Solar radiation in the wavelength of ultraviolet light can be rather deadly if overexposed, as UV radiation has a tendency to cause pyrimidine bases such as cytosine and thymine in DNA to form covalent bonds with each other. In simple terms, it tends to ruin your DNA, causing various types of damage that an astronaut or future Mars inhabitant would not want to experience. Since Mars has no atmosphere or a magnetosphere to absorb and deflect the incoming death rays, a viable solution is to live underground, preferably at a depth of 1 to 1.6 meters. Underground bases could be shielded by the sun's radiation, perhaps carved into ancient lava tubes or dug using machines. With a pressurized habitation module and radiation-resistant EVA suits, humans could very well inhabit our red neighbor, albeit with sustained resupplies. As humanity progresses, the prospect of a colonized Mars seems less like science fiction and more like a viable future. Thank you very much for watching this video. It took me a very long time to research and edit, so please like and subscribe if you want to support the channel. And feel free to comment your opinions or for future video ideas.